Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
The design of a modern car is quite complex, even if we are talking about the most budget models equipped with a limited number of different equipment and systems. But one of the integral elements of most vehicles is a differential, DFC. It is necessary in the car to provide different revolutions in the rotation of the wheels. Not everyone understands why it is needed on a car, who is responsible for such functions, and how the differential works. In short, a differential is an element or mechanism of a vehicle transmission that is designed to redistribute the torque supplied to it. This is what gives the wheels different angular speeds as needed. But this component requires a more detailed study. Why it's needed? To begin with, we need to understand what differentials in cars are. Not everyone knows, but in cars, the wheels rotate at slightly different speeds. This becomes most noticeable when entering corners. During this maneuver, each wheel travels a different distance. The inner tires travel a shorter distance than the outer tires. This causes the wheels that travel a shorter distance to travel the same distance as the outside wheels, but at a slower speed. That is, when the car turns left, it is the left tires that spin slower and the right tires spin faster. And vice versa. Do not forget about the difference in the distance covered between the front and rear wheels. If it is a car with a mono-wheel drive, front or rear, here the difference in rotation speed between the front and rear tires does not play a special role. They are not connected to each other and carry out their rotation independently. However, the drive wheels are always connected to each other. Their rotation is set by the engine and transmission. They need to drive both wheels, but at different speeds. This raises a legitimate question as to how this is possible if there is only one engine. This is where it becomes clear why the car needs this differential, so that the two drive wheels can rotate at different speeds. In the absence of a DFC, even turning a small angle would become a whole problem because both wheels would be spinning at the same speed. During the maneuver, one of them would slide or slip. Constant cornering in this mode would quickly wear out the car axle. As you understand, the differential really performs a very important task because it provides the ability to move comfortably and safely on the roads, easily enter corners, and make turns in a limited space. Application considerations. DFCs are required to ensure torque transmission to the drive wheels and drive axles. If we talk about trucks and cars, then here the vast majority of cars, regardless of the type of drive, use an interwheel type of differential. It is required to transmit the necessary rotation to the wheels. There is also a concept of interaxle DFC, which is responsible for the distribution of torque between the axles. Such a design is used only on machines with all-wheel drive. Depending on the gear used, differentiate between worm, bevel, and cylindrical mechanisms. And if we start from the number of teeth on the gears of the axle, then the division is divided into asymmetrical and symmetrical. In the case of the axles of cars on all-wheel drive, the optimal choice is considered asymmetrical type with a spur gear. This is due to the ability of such a system to distribute the moment proportionally. For vehicles with rear and all-wheel drive, it is customary to use conical symmetrical DFCs. But experts note that the most universal option is precisely the worm variant. It is suitable for all devices and for all types of drive. Scheme of operation. For a clear understanding of the essence, it is necessary to understand how the differential works on cars. Since the most relevant variant for passenger cars is the conical wheel differential, it is worth considering the operating principle of the system by its example. This will allow you to understand how the automobile differential is designed and how it functions in various operating conditions. In straight-line driving, when cornering, slipping, it is worth considering each situation separately. Straight-line driving. When the car is moving straight, the loads between the wheels are distributed evenly. They move with the same angular velocity. Satellites located in the DFC housing do not rotate around their axis. Torque is transmitted to the half axles by means of a fixed gear mesh from the driven pinion of the main gear. Turning. Here we are talking about a slightly different principle of operation of the automotive differential. In this situation, loads and resistance forces are distributed in a certain way. The inner wheels with a smaller turning radius have a greater resistance force than the outer wheels. As the load increases, this forces them to reduce their rotational speed. This causes the outer wheel to move over a larger radius, and therefore the angular velocity increases. This is necessary for smooth turning without obvious slippage. In other words, the DFC sets the wheels to a different angular velocity. When the half axle of the inner wheel rotates at a lower speed, this causes the satellites to move. They use a bevel gear to increase the rotation speed of the outer tire. The torque coming from the main transmission does not change. Traction. Even if the vehicle is traveling straight, but in off-road or slippery conditions, various stresses, including slippage, occur. When one wheel slips, it loses traction on the road surface. In parallel, the other wheel is loaded more heavily and its rotational speed is reduced. This is similar to a turn in the driving pattern. Only in this situation, the car is harmed because the slipping wheel can potentially take all the torque from the differential, and the loaded wheel will stop rotating. This would force the car to stop. To solve this problem, directional stability systems are used, as well as automatic and manual locking of interaxle differentials, which is relevant for off-road cars. Read also what the pressure in the cooling system should be, how it is created, and what to do in case of deviations from the norm. The question of locking in general deserves separate attention, because without it, all sorts of shortcomings of the classic DFC design can manifest themselves. Why blocking is necessary. Faced with situations when the differential satellites turn on, after normalizing the state of the machine, it is necessary to return everything to the initial state. That is, the wheels need the same torque again. To do this, the satellites must be locked or the torque must be transferred to the loaded wheel axle. This is especially important for vehicles characterized by high cross-country ability and designed for off-road use. That is, we are talking about all-wheel drive vehicles. And it is not only about off-road. Such cars are characterized by the fact that they have 3 DFCs in their design. 2 of them are inter-wheel, and another one of interaxle type. If the car loses traction with the surface with at least one wheel, the torque on all other wheels will tend to 0. And then the situation will turn out that the car will not be able to drive. This is to the question of what is the differential lock on the car, and what gives the presence of this system. To prevent such unpleasant situations, there is a so-called differential lock. It can be partial or full, and is divided into automatic and manual. Self-locking DFCs have proved to be excellent. Their peculiarity is the distribution of torque on the basis of analyzing the difference of values on the axles, or on the basis of the parameters of angular velocity of each wheel. The most complex from the point of view of realization is considered to be electronic locking. It works in tandem with the directional stability system, and they are closely interconnected with each other. A special sensor is responsible for controlling the parameters when the car is moving. Receiving information from the controllers, the system changes the work of the car in automatic mode. The driver does not have to do anything for this. Classification of DFCs by locking method. Despite all its objective advantages, the free differential is characterized by one significant disadvantage. When one of the wheels starts to slip, the satellite spins and transfers the full rotational impulse to the slipping tire. This causes the wheel to spin at high speed. But the problem is that the adjacent tire, which is firmly on the ground, does not rotate. Such a process is extremely dangerous when traveling at high speeds. It is not difficult to imagine how the road forms a section that is unevenly covered with a layer of ice. If you drive on such a section on a car with a free differential, which has no locking, it threatens the most dangerous, uncontrollable skidding. To prevent such dangerous situations, differentials began to be supplemented with locking systems. There are several variants of differential locking, each of which has its own principle of operation of blocking mechanisms. The following methods are considered: manual locking, self-locking, electronically controlled. All of this helps to solve the problem of preventing slippage. The essence of all systems is to temporarily stop one of the mechanism elements. This can be realized by blocking one wheel, half axle, DFC, or the entire engine. Depending on the method of realization, it is accepted to consider 3 locks. Manual cars with forced manual locking of the differential are quite common, despite the presence of more modern and improved systems. Read also, improving the dynamics of the car. One of the sport's options, manual locking, is considered the simplest as it requires the direct participation of the driver himself to disengage it. To realize this function in the vehicle, special buttons or levers are installed directly in the cabin at a certain distance from the driver so that he can easily reach the control. Using this lever or button, the vehicle blocks the rotation of the satellite along its own axis. As a result, the planetary gear becomes a standard conventional clutch. These shifting procedures should only be performed when the vehicle has come to a complete stop and the clutch pedal has been depressed all the way. Dasvachin vot nastina radid zastasovali blokovania thot. Koli автомобиль рухаться на невеликій швидкость. Долаючи складненькі бездна. Якщо дефев включити управління практично зника, машина буде прагнути рухатися промовлено. За огляду на ці нюанси, можна за упевненістю сказати, що керування ручним блокуванням вимагає обов'язкова наявність певних новичок у майстерність видавода. Ручне блокування реалізовано на досить популярних позашовиках, як оснащується жорстким типом рами. Самоблокування девцер стали наступним кроком і досконалень цього механізму. Система прекрасно підходить до повнопривідних авто, але ось щодо того, чи потрібне таке блокування диференціала розпорядникова. Приведу виника багато запитань. Якщо говорити стосовно повнопривідних авто, то самоблокування тут проявило себе дуже гарно. І ова було розроблено за метою прогноз за паралельним спрощенням самого керування транспортним засобом. Все ж ручне блокування, попри вираз свої переваги, експлуатаційні особливо зручні. Можна відлити туголовин системи самоблокувальних DFC, speed sensitive. Such differentials are activated when the half axles start to rotate at different angular speeds. Part of the structure is mounted on the cup of the DFC, and the second part is located on the axle. In normal motion, the working elements of the clutch realize independent movement, which does not change the rotation of the half axles. If the angular velocity of one wheel exceeds the speed of the other, the viscomuff is activated, which allows automatic braking. When the speed decreases, the friction force also drops, making the units independent again. These systems are relevant for those who do not intend to conquer complex off-road, but want to be sure of safety when driving on dirt roads or simply in urban conditions. Torque. It is considered a more modern and highly efficient system. These DFCs come into operation when the rotational speed of one of the available half-axles drops. The node is able to control the parameters of rotation speed, and also to reduce them completely in automatic mode. The design is presented in the form of a conventional free differential, supplemented with friction spring-loaded speed dampers. They are located between the cup of the DFC and the half-axles. The action is based on hypodyne gearing, capable of unlocking spontaneously. A fairly common variant of the system, which is further divided into 3 subspecies. They are designated as T1, T2, and T3. Electronic control. It is important to realize that mechanical locking is not the only development for modern cars. Not only it allows you to improve the passability of vehicles, as well as to improve the quality of control over the behavior of the car on the road in different conditions. A good example of a worthy alternative is a system where the transmission is controlled by special electronics. We are talking about the so-called traction control. This is a scheme that realizes the control of traction and grip of car wheels. The basis of traction control is quite simple. The system monitors and corrects the speed of rotation of wheels, using special sensors controllers for this purpose. When the wheel starts to slip, the brake is activated in parallel, and the torque is transferred to the other half axle. Initially, it may seem that in this situation, the behavior of the car will be similar to the situation when the differential is blocked. In reality, electronically controlled systems have proven to be noticeably more effective than mechanical locks. In addition, they are structurally simpler and have improved reliability. An interesting feature of traction control is that it does not interfere with the differential. On the contrary, the system complements it very successfully. This is due to the fact that modern SUVs have begun to actively equip DFCs with electronic control. This system is called traction control. Summing up, we can say that differentials are created to increase the level of safety and comfort when driving and maneuvering on the tracks. All the disadvantages that are associated with differentials relate to their use in extreme conditions and off-road mode. And this problem has also been solved with the help of various locking systems. Differentials are called simple, but at the same time incredibly important components of the drivetrain. And this is more than a fair characterization for these units. In conclusion, the differential is a crucial component in a car's drivetrain, allowing the wheels to rotate at different speeds while maintaining power and control. This functionality is essential for smooth cornering and overall vehicle stability. By understanding how a differential works, you can appreciate the engineering that goes into making your driving experience safe and enjoyable. Whether you're navigating tight turns or cruising down the highway, the differential plays a vital role in ensuring your car performs at its best. Thank you for watching, and we hope you gained valuable insights into this important automotive feature.